Hello, my dear. Welcome to IMS GATE Academy. I hope you are all good and your preparation going to be in a right direction. So, for your enhance your preparation, we again come in front of you through a GATE series through a formulas. That means a revision series through a formulas. Why this is important? See, my dear. See, if you study one subject at a time, it is not difficult. If you study two subjects in a day, it is not difficult. But you perform approximately 8 subjects in a 3-hour session for the GATE exams of the GATE. This is very difficult to memorize all the formulas of the concerned subject. So this session will definitely help you to enhance your preparation and also how we are thoughts, how to proceed of any questions why? Because beta, see, in the GATE examination, the GATE always they form new question. So if you form if there is a new question, how to click, how to approach that question. See, sometime we have all the formulas, but we cannot proceed. That is also we will cover in this part. So there is how to proceed of a given situations, how to handle, how to click the correct answer with a minimum knowledge of that particular topic. So really this will help you, right? Okay. Now, see beta, if you talk about thermodynamic subject, what is your strategy? See, thermodynamic subject, what is the problem in the thermodynamic subject? See, this subject is very easy, but you cannot focus when you study in the semester examination. And ultimately, you are doing very well, but the marks you score in the semester examination, there is very less score you can get in the exam. So this is also a very, why? Because during the BTech, we cannot able to understand the total of the thermodynamics, how to approach, how to study. Okay, so for that, we design some concept through that formulas. What is that, beta? See, if we talk about, I ask one questions, okay? Through a question, I ask one little bit question to focus on this one. See, what is that? What is that? What is that? How to approach, how to use the formulas. Okay, so all isothermal process all isothermal process must be all the isothermal process must be reversible process. My dear, whether this statement correct or not, that means this is true or false, just apply your brain. That means all the isothermal process must be irreversible, whether it is correct or not. See, you know all the formulas. And you know what is the reversible process, what is the isothermal process. But you have, in this type of situation, when you arise, no, Uttam, it is false. Uttam, you are wrong. The first question in front of you, and this is wrong. So please continue during the 3 hour. Really, I give you some content which is never found in YouTube channel anywhere. Okay. So Uttam, your answer is wrong. So all the isothermal process must be reversible process. This is false. The statement is false. Now, we know that situation. If you know that all the isothermal process must be reversible, and I say that it is false, but you cannot able to judge that. See, this is the concept. You cannot able to judge that. How can you say that this statement is true, or how can you say that, Uttam, this statement is false? These have a basic insight in this. What is that? See, first we know that what is the reversible process. Okay. I'm not giving any definition, so don't bother about that. It is not a boring session. It is a very highly energetic session. So I'm not giving any formula definition. So what is the reversible process? In the reversible, there are two: either internal reversible, and external reversible. That means combination of these two, internal reversible and external reversible, that is called a reversible process. That means for the process has to be reversible, it must be internal as well as external process. Now we will see how. See, see, if there is any container, piston cylinder arrangement, and this is our system, and this is our system, and it will, system have a temperature T1, system has a temperature T1, and the surrounding have a temperature T0. Let's reservoir, and this will transfer heat from this reservoir to this system. When it is transferred, that means T1 is less than T0. Then this is possible. Okay. When the heat transfer is possible, when system temperature is less than the surrounding temperature. Okay, this is the situation. I will arise the situation. I will create a environment, a situation to understand this statement. So take one piston cylinder arrangement in which the system have a temperature T1 and the surrounding have a temperature T0, and we supply a heat to the system if and only if the temperature of the system is less than the surrounding temperature. Okay, no problem at all. Now, how the system is isothermal? When T is not changing while we supply the heat. T will not changing while we supply the heat. That means, what is that? See, very important. That means if T1 is remains same, then it is an isothermal process. Yes or not? Isothermal process. Then it is an isothermal process. Right? For the system, it is isothermal. That means in that situation, we can say that the system is in isothermal. Now, this is this probably you know. Now, see, how can we see that the system, the reversible process? That means how can we make the system is internally reversible? That means the piston will displaced very slowly. That means a quasi-static process. A quasi-static process must be an internal reversible process. That means if it is very slow process, if it is very slow process, then it is reversible isothermal, particularly, but it is internal, but it is, so it is a very slow process, that means it is reversible, but this reversible is not total, it is internal reversible. Right, it is internal reversible. Now, that means if the process will execute very slowly, then it is internal irreversible. Now, how to make external reversible? See, if the temperature difference between system and surrounding is very infinitely small temperature difference, in that case the heat will transfer. So in that case, that is a external reversible. That is in the case of external reversible. Thank you, Bipin. But at somehow, why? Because this heat will transfer in the two mode. Either will very close the temperature, either there will have very high temperature. So you don't know that what is the temperature difference. So it may be internal reversible, but it may be external irreversibility. Why? Because the temperature change between the heat transfer is very large. So it may be internal reversible, but external irreversible. So the total process will be irreversible. That means irreversibility will vanishes. If in the process, if any one process is irreversible, then the total process is irreversible. So it is not a must. Here the term must is there. That means all isothermal process must be reversible. No. All isothermal process may be reversible. It is true. It is true. But there is must is there. So must is wrong. Must is wrong. Okay. So it is internal. How to make external irreversible? Reversible if the temperature difference is very small. Right? So there is no any criteria to difference the temperature. Why? Because T1 is less than T0, so that heat will transfer, and it may be high temperature difference and it may be low temperature difference. So it may be external irreversible. That means total is irreversible. That means total reversible. That means this reversible process is when possible, when the external as well as internal is reversible. Internal reversible when the process is very slow. External reversible when the heat transfer at a very infinitely small temperature difference. Okay, beta. So this statement is false. Right, Uttam? Okay. Now we'll take second one. What is that? See, what is that? The second term is cyclic integration of dq. Cyclic integration of dq tends to 0. Cyclic integration of dq tends to 0 for irreversible heat engine. For irreversible heat engine. This is true or false? Anyone, please? 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 That means cyclic integration of dq tends to 0. That is, this is minimum, tends to 0 for irreversible heat engine. This is true or false? Uttam, please reply. This is true or false? This is true or false? Okay, we don't know. If you not replying, so I can say that we don't know. Let's check. Okay. Yaswant Vajbal. True. Okay. This is true. Yaswant says that this is true. Yes, Yaswant, you are right. Why? Because you are my student. Okay. Yaswant, it is true. You are my student. That's why you're telling. I think no other than of my student can able this answer. I know. Yaswant, you are my student. That's why you're giving the answer. Otherwise, another student cannot give the correct answer. I know. But how? It is very important. See beta, we make a heat engine. This is your heat engine. See, this is your heat engine, and heat engine will produce W net when it takes a heat from a high thermal reservoir, reject a heat to a low thermal reservoir. This we'll know from the second law. Now, this is our system. Now, how can you say that? See, what is a cyclic? If this is the cyclic process, heat engine will execute in a cyclic manner. So it is a cyclic process. So what is the cycle, beta? That means cyclic integration of dq is what? From this system QH is positive. Why? Because heat will add to the system. QL will negative. Why? Because it will reject from the system. Okay, and this is for the cycle. That means this is also cyclic integration of dW. Yes or not? Yes or not? Why? Because the cycle according to the first law of thermodynamic. That means this is your what? W net. This is what? W net. That means cyclic integration. Very important. That means the cyclic integration is equal to W net. Now, my dear, what type of cycle? The cycle is irreversible. The cycle is irreversible. So, due to irreversibility present in the cycle, there must be heat dissipation. There must be heat dissipation. That means in that system, heat will lose. And this loss will measure the extent of irreversibility. This heat loss measure the extent of irreversibility. Higher is the higher irreversible of the system, higher is the higher loss. Lower is the lower this heat loss, higher is the higher chance to cycle is reversible. That means here, if the engine, let's suppose if the engine is highly irreversible, if the engine is highly irreversible, so there may be chance that this heat loss is very high. If heat loss is very high due to irreversible process, so the network, the chance of the network is to reduce. The chance of the network is to be reduced. If it to be reduced, that means W net tends to 0. W net tends to 0. If W net tends to 0, obviously cyclic integration of dQ tends to 0. That means this cyclic integration of dQ tends to be 0 for irreversible cycle. For irreversible cycle. Yes or not? Yes or not? Everyone please. Yaswant, it is good, beta. Yaswant, it is true. It is true for irreversible cycle. Now, so what is the this questions gives you very inside concept to revise all the theoretical part. Yes, okay. Thank you, Nuru. Nuru, I give another sort of the questions. Please see. Question number 3. What is that? Please give me a reply. All of you, please give me a reply. All of you. See, a process, very intelligent question. A process with no net change in entropy, a process with no net change in entropy of the system must necessarily be reversible and adiabatic. This is true or false? Please, everyone. This is true or false? That means this is true or false, everyone. A process in which no net entropy transfer, no net entropy change of the system must be necessarily be reversible and adiabatic. Please, true or false? This gives one insight of this. Everyone, please. False. Uttam, it is false. It is false. Yes, you are right. It is false. Yes, you are right. But how? How can you say that? Must necessarily it is not. If here it is, need not be written, need not be, then it is true. Yes or not? then if this statement is there, then it is true, but according to this statement must be necessarily it is false. Not conducting, not non-conducting, matlab non-conductive, non-conductive. No, it is not like a non-conductive. Okay, see, see, what is the entropy change? S2 minus S1 is equal to heat transfer from the process 1 to 2 divided by temperature plus S of generation. Yes or not? Yes or not? This is your entropy balance. This is the entropy balance, you know everyone. This is the formula of entropy balance, you know everyone. Okay. Now a process with no net change in entropy. That means this will 0. No net change in entropy. That means this is 0. According to the question, this is given. Okay, this is given. Okay, no problem. This is given. Now that means what, beta? That means what? This is isentropic. This is what? Isentropic. Yes or not? Now this is isentropic. Now see, if we make the process isentropic, that means no net change in entropy. We done that, no net change in entropy. How? See, there are two possibilities. Very important. There are two possibilities. Why? If process, if it is reversible and adiabatic. If it is there, reversible and adiabatic, that means reversible, that means what, beta? S generation is 0. Adiabatic, that means heat transfer is 0. That means this 0, this 0. That means this 0 plus this 0 is equal to 0. That means a process with no net entropy change may be reversible and adiabatic, but it is also 0. Isentropic process is also, this process is delta S2 minus S1 also be 0 when, see one thing, let Q1 to 2 divided by temperature, let's suppose this is your minus A. Let's suppose this is your minus A. That means heat will reject. Heat will reject to the system. And this S generation is positive. That means we take let. This is let. That means S generation will take plus A. Plus A. That means minus A plus A combined with isentropic. That means no net change in entropy, no net change in entropy, not must necessarily. It may be reversible adiabatic, it may not. See, this minus A, that means non-adiabatic, right? That means non-adiabatic, and there is a generation, that means irreversible. So, irreversible non-adiabatic process may be isentropic. So, isentropic process need not be reversible adiabatic process, but reversible adiabatic process must be isentropic. Yes or not? Must be isentropic. So, the statement is false. Everyone, it is clear? Everyone, it is clear, beta? Everyone, it is clear? Now, if it is clear, we'll go to the next sort. What is that? This sort is very important. Now, what is the next one? See, if you think like that, all slow process necessarily be reversible. Be reversible. This is true or false? Everyone, please. Everyone, please. This is true or false? Please think. All slow process necessarily be reversible. This is true or false? Everyone. false, false. Okay. Okay, right. We'll check. We'll check. If you say that false, we'll check. See, beta, my dear, it is not a matter of choosing true and false. It is a matter to analysis your concept. That means also process is necessarily be reversible. If you telling false, just analysis, start with analysis and match with my tuning so that you get comfortable for that. How? Let's see. See, all the slow process must be internal reversible. That means if there is a piston cylinder arrangement, if the piston is rising or falling in a very slow manner, that means it is a internal reversible. That means beta, slow process must be internal reversible. Must be internal reversible. That means if you have false, since all slow processes must be internal reversible, right? But may not be external reversible. It is not necessary that it is external reversible. Yes, it is in all the slow process is internal reversible, but may not be external reversible. Okay, may not be external reversible. So if they are external reversible, that means the net process, that means if internally is reversible, externally is irreversible, internally is reversible, externally is irreversible, then the net process is irreversible. So then the net process is irreversible. Okay, then the net process is irreversible. That means the net process is irreversible. That means all the slow process necessarily be reversible. It is false. It may not. Why? Because the system may be externally irreversible. Okay. See, I give you one shot. See, beta, I give you one subtle concept you can never found in any book. I give you one subtle concept. What is that? See. What is that, beta? See, note. See, beta. Reversible process. Very important. Listen very closely. Reversible process, it has to be internal reversible. Internal reversible or total reversible This is very important. If you can say that, sir, reversible process. What is the reversible process? Reversible process must be internal reversible or a total reversible. What is the total reversible? The total reversible is, sir, internal plus external reversible. Okay, no problem at all. That means reversible process either internally or internally plus externally. It is very clear. Okay, no problem at all. Now, see, very important. If the process is internal reversible, must be a quasi-static process. must be a quasi-static process. Must be a quasi-static process. Yes, but a quasi-static process need not be reversible. A quasi-static process need not be reversible. Yes, reversible process, if reversible process must be internal or total. If the reversible process is internally reversible, particularly if total it is okay, but internally reversible, that process is quasi-equilibrium process. But the quasi-equilibrium process need not be reversible. Why? Because it may be external irreversible. It is right. It is right. Everyone, it is right. That means internal process, internal reversible is a reversible process. It is a kind of a reversible process. Okay. And internal reversible is a quasi-static process. But the quasi-static process need not be reversible. Why? Because it may be external reversible, external irreversible. It may be external irreversible. It is clear, everyone? It is clear, everyone, please? Uttam, it is clear, beta, everyone, please? This is the very subtle concept is there. This is the very subtle concept, okay? Now, take one another shot. See, next, yes, Yaswant, okay. Yaswant, Uttam, Nupur, Nuru, please reply the next formulas. Right. See, if we say that, this is a very interesting session, I know. Why? Because all the cancer in the student community with respect to the subject of thermodynamics will just remove all the cancers within your body with respect to thermodynamics, will filter for this session. If you stay up to 3 hours, automatically you feel better. Okay, and this lecture will free on the YouTube channel, so you can. This type of the session will never found on the YouTube channel. Just a challenge. I give you a challenge. So okay, no problem. Next, a throttling of an ideal gas. A throttling of an ideal gas. A throttling of an ideal gas is approximately an isothermal process. True or false? Everyone, please. True or false? Everyone, please. Yaswant, Uttam, Nur, please reply, beta. And throttling process, just take a time. It is not necessary that you just reply immediately. No. A throttling process of an ideal gas is approximately an isothermal process. True or false? True or false? Just reply. True. Nupur, true. Yaswant, Uttam, please, beta. Nupur says that it is true. Okay. True. Uttam, true. No. Don't give the explanation. Nupur, it is okay. I will provide you. Okay. Uttam, true. Manju, Katri. Oh, false. Okay. Okay. Manju. Now next. Yaswant, please reply, beta. Yaswant, please reply. Yaswant, please reply. It is true or false? Okay, we don't know. We don't know. We'll check. Throttling process, that means, what is the, you know the throttling process? We pass the fluid in a very constrained passage. That means, see, this is a channel and this is a throttling process, okay? This is a throttling process, okay, beta? This is a throttling valve, okay? And we know that during the throttling, we cannot bother about the heat transfer. So, we will take a heat transfer is 0. Yes, one, false. Okay, beta, we'll check. Now, this is your inlet section and this is your exit section, okay? This is your inlet section and we know that during the throttling process, during the throttling process, enthalpy at the inlet is approximately equal to the enthalpy at the exit. Yes or not? Enthalpy at the inlet is approximately equal to enthalpy. That means this is approximately isenthalpy. Now, that means inlet enthalpy minus exit enthalpy is approximately 0. Right? Now, if there is a ideal gas, if this is your ideal gas, so what is the change in enthalpy for the ideal gas? The change in enthalpy for the ideal gas is nothing. It is Cp delta T is approximately 0 for ideal gas. Cp delta T is equal to 0 for ideal gas. Now beta, it is said that means delta T approximately 0. That means temperature at inlet is approximately equal to temperature at exit. Yes or not? Yes or not? That means at inlet cross-section area temperature and exit cross-section area temperature is same, but it is not necessary that this temperature is throughout constant from I to E. See, what is isothermal? That means a process from I to E, the process is isothermal. That means in between I to E, each and every point the temperature is same. That is called isothermal process. But here only inlet and exit. That means it gives the only inlet and exit section. It is not gives the information in between these two. That means there are inlet cross section, there is exit cross section. At this point, yes, at this point temperature is constant, but it is not necessary in between I to E. So it is not necessary that isothermal process. It is not necessary that. That means we can write that. We can write that is temperature. We can write here, beta. What is that? Temperature before throttling is equal to after throttling. After throttling. But this doesn't means that temperature remain constant through entire process. So it is false. So it is false. Everyone please. It is okay. Everyone please. Nupur, Swant, Manju, it is okay, beta. So you don't think that, sir, this is, it is not thing, you think like that, sir, it is, what is that? It is very easy. No, it is not easy, my dear. Yes, during the session, it may be 1-2 questions are like that, you can say that. But other than that, you have a pressure on your mind. So, next is there. Please be prepared for the next one. Area under the closed loop. Area under the closed loop representing a thermodynamic cycle in a TS diagram. In a TS diagram signifies that net work done in a cyclic process. Please reply everyone. This is true or false? Please reply. Please read question very carefully. Area under the closed loop representing a thermodynamic cycle, okay, in a TS diagram signifies that net work done in a cyclic process. Please. Okay, it is true. Other than that, other than Manju, okay, work done is 0. True. Yaswant, true. Okay, Nupur, Nuru, no, don't give any explanation, beta. Nuru, just tell true and false. Just think and then give the reply. Just true and false. Okay. You say that it is true. I give one shock. It is false. It is false. You are not every time true in your life. Think. See, that's why I'm just one minute back say that it is not easy session. It's have your patience level and your hardcore concept in the thermodynamics. Then you can able to understand this session. Okay, how it is false? I am telling that it is false. Just think. I read once again. Area under the closed loop representing a thermodynamic cycle in a TS diagram signifies that the net work done in a cyclic process is true or false. That means this signifies that net work done in a cyclic process, it is true or false. Let's see. Will not take much more time. See, if you draw TS diagram, okay, TS diagram, and we draw a closed loop. This is our closed loop, okay, this is our closed loop, okay, no problem at all. What is this area represent? What this area represent? Very important. See, there is a one click is there. What is the area represent? This area represent integration TDS, yes or not? That means this is area. Yes or not? Integration TDS, please, yes or not? Integration, this area represent TDS, integration of TDS, right? If there is a PV, integration of PdV, area, this area represent TDS. Now, see, TDS integration, see beta, very important. Integration TDS. No. Integration TDS is equal to heat transfer if and only if the process is reversible. Here it is not mentioning it is process reversible or irreversible. See, area under the closed loop representing a thermodynamic cycle in a TS diagram signifies the net work done when the process is reversible. But there is no mention any reversible or reversible. That means this integration TdS is equal to dq only reversible process only. And if area under TdS is equal to dq, and according to the first law of thermodynamics, dq is equal to dw, that means first it is dq or not? Yes, it is TdS, no problem. TdS is the integration over the loop. What is the TdS? TdS is the integration over the loop. So it is okay. So TdS is TdS, integration and TdS is for any process. But integration TdS is equal to dq only for reversible process. So once it will dq, then it is equal to dw. And this is for first law of TD. So this equal to this, only the process is reversible. So it is false. Not all thermodynamic process. This is thermodynamic cycle, but the cycle is reversible. It is right? Everyone please. Manju, if there is a net heat transfer only for the reversible process. So in a thermodynamic process, the area under the curve TdS, area TdS, and that TdS, it is equal to heat transfer only for the reversible. So here when it is true, see, when it is true, area under the closed loop representing a reversible thermodynamic cycle, a reversible cycle in a TdS diagram signifies that the net work done in the cycle process, then it is true. Here reversible cycle must be mentioned. Then we can say that this signifies the work. It is clear everyone? Manju, Uttam, Yaswant, Nuru, it is right beta? It is right? Clear? It is not a very light session beta. It is very, very, very intelligent session. So be prepared for that. If you have a now next. Next. This is also very important. All the question, what I'm telling now, all the thermodynamic questions are very, very unique. And you have to grasp more and more concept. And please, I request you, please sit there through a notebook. Just note down the important word. If you want to that, again, sir, please, again you can reply. I am also again reply for that better clarification. So you don't sigh or don't bother about that, okay? Now next, will not take much more time. So next one. So this is the question next. Just revise. This is the revision of all the thermodynamic subject. Just revise. A process with zero net change. A process with zero net change in entropy must necessarily be isentropic. This is true or false? Everyone please. Why I'm taking this such type of situation? Why? Because in the examination hall, Nuru said that true. Okay. Yaswant, Manju, Nuru says true. Okay, beta. We'll just give you reply. Other than that, Yaswant, Manju, true. Okay. Manju said that true. Okay. Yaswant, Yaswant, Yaswant. Okay. This is false. See the beauty. This is false. This is false. How? Okay. See, let's see. Just think. If I'm giving the, I give you 2 times of the time. Yes, Nuru. I give 2 times. One, when we write the question, just think, reply true and false. Once I give the reply, yes, it is true or false, then again think. It's have a better clarity. See, a process with zero net change in entropy. In the question it is saying, that means delta S net is equal to 0. It is given. Okay. It is given. Okay. Now, that means S2 minus S1 is equal to 0. Yes. That means S2 is equal to S1. Okay, no problem. Now, from here, you have a confusion that, sir, when S1 is equal to S2 is same, then the process is isentropic. No. That means, see, I give you one thought for that. This is very confusing, yaar. If you draw a TS diagram, no problem. And we want that, this is the property, yes or not? Entropy is the property, yes or not? That means initial property and final property are same. That means there is a cycle. And is the cycle, this is point 1 also, this is point 2 also. So that S1 equal to S2. Now, see, from process 1 to 2, throughout, this is the process 1 to 2, 1 to 2, 1 to 2. In a 1 to 2, there is an infinite number of processes. If you take this process, in this process, the entropy is this one. If you take this process, the entropy is this one. If you take this process, entropy is this one. That means, though S1 is equal to S2, but during S1 to S2, the entropy is changing. Let's suppose this is your S1, this is your this is your 2 entropy, this is your 3, this is your 4, like that. That means, though S1 equal to S2, but during S1 to S2, the entropy, here entropy is differ, here entropy is differ, here entropy is differ, here entropy is differ. So during S1 to S2, though S1 equal to S2, S1 is equal to S2, that means the process is cycle. S1 is equal to S2, the process is cycling. That means 1 point and 2 point are same. Why? Because it is a property. But during point 1 to 2, the entropy will vary. At this point, let's suppose this is point A, this is point B, this is point C, this is point D. So all A, B, C, D are differ. So though the S1 equal to S2, but the entropy are differ during point 1 to 2. So we cannot say that this is isentropic. Isentropic, that means from point 1 to 2, all are the entropy same. That means if you draw this line like that, T and S, and if you draw line this 1 to 2, then this is isentropic. Why? Because at this point entropy is S1, at this point entropy same, at this point entropy same, at this point. Why? Because it is horizontal. Entropy is same. That means S1 equal to S2. This is isentropic. But if there is zero, if a process with zero entropy, zero net entropy change, must be necessarily be isentropic. No, If you draw this diagram, no, it is not saying the reversible adiabatic, na. It is not saying. It is right. Reversible adiabatic process always be isentropic. Yes, you are right. You are right. You are right, Manju. You are right. But you cannot go again same repeat concept. We have think in little bit different manner. That's why. What is the difference between this TS diagram and this TS diagram? In this TS diagram also S1 equal to S2. In this TS diagram also S1 equal to S2. Yes or not? In this TS diagram S1 equal to S2. In this TS diagram S1 equal to S2. Why? Because there is a cycle. Yes. But during S1 to S2 entropy is same or differ? It is not same. It is not same. At point A is differ, at point B is differ, at point C is differ, at point D is differ. So it may be S1 equal to S2, need not be isentropic. Need not be isentropic. It is clear, everyone, please? It is clear, everyone, please reply. If it is clear, then say yes, sir. It is clear or not? Please reply. Everyone, please, it is clear or not? Manju, it is clear. Okay, beta. Nupur say yes. Okay. Yaswant say yes. Okay. So, ready for the next question? Sir, first, yes, Uttam, what is this? Sir, first TS graph, first, this one, first TS graph in a cycle, but question in the process may be single and process may be cyclic. Cycle is what? Cycle is also process. Now, don't confuse. Uttam, you are right, but there is a confusion. Process means what? Process, that means same 1 point to 2 point. This is also, see, yes. See, this is 1 to 2. Oh, 1 second. Yes, you are right. This is, let's suppose this is 1 and this is 2. This is process. You can say that, right? Okay. Now, if you draw like that, T and S, this is not process. 1 and 2. This is not process. Whether it is process or not. Yes, sir, it is also process. It is also process. It is also process. Motivation is what? Motivation is what? Conclusion is say that isentropic. Isentropic, that means S1 equal to S2. How to make S1 equal to S2? Either your vertical line on a TS diagram, either you make a closed loop on the TS diagram, but both are the process. Okay, so don't confuse. If you think deeper manner, you get little bit confused. This is the subject of thermodynamics, my dear. Uttam, it is clear, beta? It is also process. It is also process. In both process, S1 equal to S2. But in one process, there is isentropic, but another process is not isentropic. It is clear, everyone, please? Likewise, this questions will ask. The motivation, what the question will asking such type of concept. Okay. Now, so ready for the next problem? Ready for the next problem? No problem. Okay, beta. Thank you. Now next. Thank you, beta. Thank you everyone. Your reply is my fuel. If you do better reply, see, if there is any comedian, do the comedy. Life is a comedy, beta. If any comedian performing the comedy and he performing that, so there are two things. One is that either he is boring in front of the audience, or either he are giving best for himself. In both situations, you just clap. Due to that clapping, it may be that his talent will come in front of you. So motivation is very important role play in the life. Motivation is very important. I learn with you also and you learn with me also. This life is a learning process. No one can higher and lower. Higher and lower is the relativistic term. If you are higher, someone from you also higher. So higher and lower is the relativistic term, not an absolute term. So no one in the life have absolute. Yes, these all are the relativistic. So when you are in the relativistic, now you just do your best performance. That's it. Okay. Now, okay, forget that thing. I'm not going in the detail. Okay, next sort. What is that? A piston cylinder arrangement a piston cylinder arrangement. If you say that now in a thermodynamics, basic thermodynamics, in a basic thermodynamics there is a piston cylinder arrangement, always think that a closed system. Okay, a piston cylinder arrangement contains water at 40 degrees centigrade. Heat is transferred. Heat is transferred into the cylinder. Into the cylinder. Heat is transferred into the cylinder from a heat source. At 100 degrees centigrade. From a heat source of 100 degrees centigrade, and water expanded in a quasi-static process. The process is quasi-static process. Within bracket, the process is reversible. You just check it is true or false. Just check it is true or false, please. That means a piston cylinder arrangement contains water at 40 degrees centigrade. Heat is transferred into the cylinder from a heat source at 100 degrees centigrade. The water expanded in a quasi-static process. Yes, quasi-static process. Whether the process is reversible or not, true and false. Just do this. It is true or false? Oh, Nupur says it is false. Okay, next. Yes, one say false, false, false. Okay. You are right. Now, concept is clear. Why it is false? Just do a reply. Why it is false, beta? Why it is false? Just give me a one line comment. One line comment. You more difference. Yes. Great, Nupur. That means see the temperature difference. 40 minus 100. That means delta T is 60 degree. That means there is a finite temperature difference. Finite temperature difference. The heat transfer with a finite, right Uttam, external irreversible. That means though there is an internal reversible, but heat transfer through a finite temperature difference, so it is a external irreversibility. That means a total process is irreversible. So it is false. Okay? It is clear, everyone, please? It is clear? Simple? It is clear? It is clear, everyone? Finite. It is clear, beta? Okay, now next. Now take next problem. This is the problem, like that. You have just revised that all thermodynamics. Next sort. A system undergoes a system undergoes change in state from 1 to 2, from point 1 to point 2. That means a system undergoes change in state from point 1 to 2 by two mechanisms. One is reversible and second is irreversible, right? That means there is a process, and process, what is the process? 1 to 2 process, and during 1 to 2 process, one is the reversible and other is 1 to 2 process is irreversible. So question asking that change in entropy of the system is greater in case B. In case B, this case. It is true or false? Please everyone. It is true or false? Please everyone. It is true or false? Please everyone. Yes, one says it is true. Okay. Other one? Nuru? Uttam? Uttam, just give a reply. Uttam says the false. Okay. Nuru says false. Okay. So Yaswant, Uttam, Manju says true. Oh, Manju. Manju says true. Okay. So, see, Yaswant says true. Uttam says false. Manju says true. Nuru says true. That means true is more, false is one candidate. So, it is false. Uttam, your concept is little bit good. Uttam, your thermodynamic concept is little bit good. I damn sure. I never see you. I think you are not my student. I think so that you may be, but your thermodynamic concept little bit good. But Manju, Nuru, Yaswant, Acha, Nuru says false. Okay, yes, Nuru says false. I am sir. Okay, I am sir. Okay, Nuru and Uttam also said false. Manju and Yaswant, why you are true, yaar beta? It is not true. It is a false. Oh, so give me a one single reply. Nuru and Uttam, give me a one single reply why it is. Single reply. Don't write much more. Single. 1, 2 and 3 word. Just it. What? Property. Great. See. See. A system undergo a change in state from 1 point to 2. Right? The change in entropy. See, beta, entropy is a property. Entropy is a property. And change in a property, it is independent of the path. It is depends on the point. You are right, beta. See, I give you one short note here. Then I will explain you. No problem. Just change in entropy is equal to S2 minus S1 is applicable for any process. For any process. Why? Because entropy is a property. But this change in entropy is equal to dq by t is only for reversible process. That means change in entropy is defined for any process. But the change in entropy is defined dq by t only for reversible process. It is right, everyone? It is right. So, on this behalf of that, see, there is TS diagram, okay? Just we draw a TS diagram, okay? Now, let's suppose this is point 1 and let's suppose this is point 2. we draw 1 to 2 by a reversible manner. Let's suppose this is reversible path. And 1 is irreversible manner. Let's suppose this is your irreversible manner, dotted line. So for any path, this is your S1 and this is your S2. This is your S2 minus S1. So for any path, S1 minus S2 is same. For any path, S1 minus 1. So change in entropy of the system is greater in the case of B. It is wrong. It is wrong. It is wrong. So what is the statement when it is true? Change in the entropy for the system is the same for both cases. Then it is true. Okay, you are right. It is right, beta. It is right. Everyone, please. It is clear, beta. True. Who says the true? Manju. Who said true? Yaswant. Okay. Yaswant and Manju. It is right, beta. It is right. Everyone, please reply. Yes, sir. Okay. Yes, sir. No. Now, next. This you have to always remember. Okay, this have to always remember. Now next, take another problem, take another thing. What is that? See, next shot. You are ready? Everyone, please. You are ready? You are ready, everyone, please? Yes. Now, just tell me the entropy of a fixed mass, entropy of a fixed mass of an ideal gas, decreases in every isothermal compression. Please, this is true or false? This is true or false? Please, everyone. This is a very intelligent question, so be careful. Please, beta. The entropy of a fixed mass of an ideal gas decreases in every isothermal compression. Okay, Nuru said that it is false. Okay, other than please take a time. No problem, beta. Please take your time. Please take your time. I'm requesting you. If you have a so very excited, so you may do mistake. Just think, everyone. Just reply what you, yes, true or false. Just reply. Then I give you your answer. Then again you think. Then I give the explanation. No problem at all. Okay. So other than Uttam, Yaswant, Manju, please beta, reply. Okay, false. All variable is 0 in isothermal. Okay. We'll check. Kranti, Manju says that false. Nuru says false. False. Uttam, true. Uttam, true. Yes, it is true. You are right, Uttam. You are right, Uttam. It is true. It is true. Your concept is good. Uttam, your concept is good. True. Why? Now the question is why? Just give a single, Uttam, just give a single reply. Directly proportional to entropy. Mass is directly proportional to entropy. I am coming for that. Okay, Uttam beta, just give one line. Okay, I will just discuss that. See that. See, what is TDS equation? TDS is equal to DH minus VdP. Yes or not? DH minus VdP. Yes or not, beta? Okay. And this is your ideal gas. Internal irreversibility is 0. Uttam said that internal irreversible 0. Okay, we will discuss. See, this is your, for ideal gas, this is what beta? CPDT. Yes or not? This is for ideal gas, it is due to ideal gas. Okay, okay, will come. And why? Because this is a isothermal, so this is 0. Why? Because T is constant. Okay, that means what's your, and this is for, why? This is for ideal gas. This is for ideal gas, this is for ideal gas, and this is for constant temperature. Okay, no problem. So what's your desired equation beta? TDS is equal to minus V of dP. Okay, now from here we can take ds is what beta? Minus V dP by T. Now this is according to questions. See, this is your compression. Yes or not? This is your compression. That means in the compression, pressure will increase or decrease? Pressure will increase or decrease? In the compression, pressure will increase or decrease? Obviously, it will increase. It will increase. Now, this is what beta? This is the absolute temperature. This is T is absolute temperature. So, absolute temperature is always positive. So, this is positive. This is positive. Right. And a specific volume is fixed. Why? Because mass is fixed. If mass is fixed, a specific volume is fixed. Why? Because a specific volume is inversely proportional to density. Specific volume, see, a specific volume is equal to 1 by density, and density directly proportional to mass. So if mass is fixed, volume is fixed. So this is fixed. This is fixed. It is not changing. That means this ds is, this is positive, this is positive, this is positive. That means ds is negative. ds is negative. That means ds is less than 0. That means it is true. Everyone, it is clear, beta? Everyone, it is clear? Everyone, it is clear? Yes or not? Please reply in the chat box. It is clear, everyone? So, I am coming your comment. Manju says that mass is directly proportional to entropy. It is not like that, beta. It is not like that. See, mass measure the quantity or entropy measure the extent of irreversibility. That means quality. Mass measure quantity, entropy measure the quality. That means extent. If higher is the higher entropy, acha, plus how it is? Okay. See, this is compression na. If Nuru, if you compress anything, pressure will increase. So this is positive. And T is in absolute temperature. T, this T in ideal gas, this T is in absolute temperature, Kelvin. Kelvin always positive. So this is positive, this is positive. And specific volume is fixed. Why? Because specific volume is 1 by density. And density directly proportional to mass. Mass is fixed, so specific volume is fixed. So this positive, ultimately this is positive, but there is a negative sign here. So it is negative. Clear, beta Nuru? Nuru, it is clear? Everyone please. It is clear? Please everyone reply. So Manju, mass is the quantity and entropy is measured the extent. It is not directly proportional. Okay. Now Uttam says that internal irreversibility is 0. That means internal reversible, right? Internal reversible is. So how can you say that, sir? If there is a internal reversible is 0, so how can you say that entropy decrease? Either you can say that, sir, if you compress it, if you compression, so it is not said that, beta. How can you say that it is internal irreversibility is 0? That means internally reversible. Uttam, how can you say that internal reversible? How can you say that internal reversible? It is not necessary. It is not said that compression and expansion is very slow. If the compression and expansion is very slow, then you can say that it is internal reversible. That means internal irreversibility is 0. It is not necessary. In that case, Uttam, internal irreversibility is 0. Right. Due to ideal gas. What is due to ideal gas? Yes, due to ideal gas, dH equal to C dt. But Uttam, you have a mistake where here, beta. You cannot say that in this process internally reversible. Okay, everyone please. Why? Because we cannot say here that the compression and expansion either slow or fast. Yes, it is said that every decrease in every slow isothermal compression is slow. Then it is clear. Okay, it is clear, everyone. It is clear. Okay, now next. It is clear. Okay, so take next problem. Take next shot. What is that? The specific internal energy comma enthalpy and entropy of an ideal gas are each function of temperature alone. This is true or false for please everyone. That means the specific internal energy, enthalpy, entropy for an ideal gas are each function of temperature alone. It is true or false? Please give the reply. Everyone please. True. Nuru said that true. Okay. Next. Next. Yaswant, Manju, Uttam. Other than that, beta, the specific internal energy, enthalpy, entropy of an ideal gas are the function of temperature only. It is true or false? T directly proportional, temperature is directly proportional to the K, kinetic energy. Okay, so what? So what? This is false. This is false. Don't depressed. This is false. How? How? See. We know that this is the specific internal energy, internal and enthalpy. Yes, it is a function of temperature. Yes. No problem. It is a function of temperature. Only this question asking now the specific internal energy, enthalpy of an ideal gas are function of temperature. Yes, it is true. But here is that entropy is also given. Entropy is not a function of temperature only. See the beauty. This is the beauty here. Why? See, how can you say that internal energy and enthalpy is the function of temperature? Yes, internal energy U is equal to CVT. Sorry, this is your CVT. So it is a function of temperature. And now enthalpy is what? H equal to U plus PV. For an ideal gas, PV equal to MRT. So this H is also a function of temperature. No problem. So H and U are the function of temperature. H and U are the function of temperature. But entropy it is not a function only, temperature only. How? See. But entropy change, that means delta S is equal to S2 minus S1 is what, beta? What we know that? Cp, you know that this formula ln T2 by T1 for ideal gas minus R ln P2 by P1. This you know. This you know. R ln P2 by P1. So in this case, delta S is the function of this temperature and pressure both. Temperature and pressure both. And if delta S is the function of temperature and pressure, and we know that P V is equal to R into T. So if this is function of pressure and temperature, automatically it is a function of a specific volume or specific volume. So entropy is the function of temperature, pressure or a specific volume, but specific internal energy and enthalpy are the function of temperature only for an ideal gas. It is clear, everyone? It is clear, everyone, please? Nuru, it is clear, beta? It is clear? It is clear? Everyone, please? It is clear, na? Okay, okay. So don't mistake, है ना? Just be careful, beta. Okay. Now next, just give this one. A process that violates the second law, violates the first law. First law. It is true or false? It is true or false, beta? A process that violates the second law violates the first law. It is true or false? It is true or false? Please everyone reply. Uttam, false. Okay, now next. Nuru. Yaswant. Everyone please. False. Okay. Next. Anyone? Okay. So, yes, it is false. Give me a one line answer. Uttam, Nuru, please give me a one line answer on the reply chat box. In the chat box, please reply. Please reply, beta. Everyone. Qualitative. Okay. Huh. Okay. Yes, you are right. Okay. Yes, qualitative. Okay. Yes. See, I will give you very simple logic for that one. See, first see that what is the first law? This is a conservation of energy, yes or not? Conservation of energy, yes or not? Yes or not? This is the conservation of energy. Okay. Now, all the spontaneous process or a natural process are a irreversible process. That means one way. Our growth from child to old, not old to child. So there is a one way. Water fall from high to low. It is never go from low to high. If you go, then there is a external work. So naturally, all the spontaneous process are irreversible process. That means one way process. Okay. Now, if you do a process, let's suppose a spontaneous process, a natural process, is a one-way process. Is a one-way process. It is always forward. Okay. Now, not reverse. Now, see, we make some arrangement. See, beta. Okay. So, this is your first law. And this is your second law. Right? If we connect the first law, if you switch on the first law, the process will happening. The process will happen. But it is not necessary. It is not necessary that you must be required the connection of the second law. The process will happen only responsible the first law. It is not necessary the second law. That means this is the process. That means if any process violates the second law, need not be violates the first law. Why? Because process is always happening. So if the process is happening, it is not necessary that the second law is applicable or not. No, it is not applicable, but process is always happening. That means a process that violates the second law, violates the first law, no. And first law gives the conservation of energy. That means if any process will taking place, minimum condition it to be follow the first law. It is not necessary that it follow the second law. Okay, that means we can say that like that with a process that violates the second law, that means it violates the second law, does not mean that violates the first law. It is clear, everyone, please? It is clear, everyone? It is clear, everyone? Yes, second law gives the, yes, now, Uttam, yes, qualitative, yes, second law gives the qualitative and first law gives the only quantitative manner, okay, conservation of energy. It is clear, everyone, please? Uttam, it is clear, beta? It is clear? Okay. It is clear, everyone, please? Okay, beta. Now next. So shall we go to the next problem? What is that, beta? Next sort. This is important. Constant pressure line. Constant pressure line on HS diagram. HS diagram always positive. Always positive. This is true or false, please? This is true or false? Everyone, please. A constant pressure line on HS diagram. This is true or false? This is true or false? False. Nuru say that it is false. Okay. Uttam, anyone, please? And count all in the series. How many you get the correct answer? Oh, Uttam says false. Anyone? 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 It is true. It is true. Don't disappoint. This is the process of treatment of your cancer in the thermodynamics. You cannot find any video on YouTube channel in this manner. That's you feel the better after the ending the session. You can feel the better. And please go through and watch regularly all these videos till the examination. And also say share that video to the another colleagues so that get benefits. Okay, beta. Just okay. Nuru, Uttam, give me a reply. Why it is false? Why you can say that this statement is false? Why? Please reply. Please reply. Why it is false? Why it is false? See, I give you. No problem. See, beta, what is HS diagram? You know? What is HS diagram? The another name of HS diagram, you know? What is the HS diagram? Uttam? The other name of HS diagram is, you know? The other name of HS diagram is molar. Yes, you are right. Molar diagram. You are right. Uttam, you are right. Now, come into the main problem. Right. We know that TdS is equal to dH minus VdP. Yes or not? Yes or not? Okay. A constant pressure. This is a constant pressure. Okay, line. So if there is a pressure constant, dP is 0. dP is 0. Why? Because pressure is constant. Pressure is constant. Okay. Now, if the pressure is constant, this is 0. That means what is left? ds is equal to dH. That means HS diagram. That means this is your H and this is your S. So, what is the slope of this diagram? dH by ds. That means dH by ds is the slope. At which process? Pressure constant is what? T. Yes or not? Everyone, please. Yes or not? This is up to this. There is any problem? No, no problem. Okay. What is the T? T is the absolute temperature. T is what, beta? Absolute temperature, and it is always positive. In Kelvin, it is always positive. That means if you draw a molar chart, if you draw a molar chart, this is the chart of molar, and there is a critical point, and if this is your liquid, this is your liquid plus vapor, and this is your vapor, yes or not? And this is saturation curve. The slope dH by dt at a constant pressure, what is give? Temperature. That means in the wet region, we know that temperature and pressure both are the collinear, the same line, the same point. That means if you draw the pressure line, how to draw? This is our pressure line. That means this is constant pressure line, also constant temperature line. Now, if you draw this one, this is the slope is constant. And what is the slope? Temperature. That means if you going little bit above, that means liquid converted into vapor. Liquid converted into vapor. That means you add energy. If you add the energy, temperature will increase. That means if the temperature will increase, slope will increase. That means from here to here, this are little bit this line. But that is this all the point, the slope is same. Now, if you draw the another line, higher pressure, constant pressure, so it will again like that. But the gap, it is not a parallel. The gap from saturated liquid to saturated vapor, the gap is more. Why gap is more? Why? Because temperature is large. If the temperature is large, this slope is higher than this slope. Why this slope is higher? Why? Because this line have a high temperature. So if there is a temperature is high, the slope will high. So slope will high. Again, if you draw, this is like that. Now, if you go into the superheated vapor, its slope is higher than this one. That means this will like that. This will like that. This will like that. This is the constant pressure line. Why it is slope will continuously increasing? Here the slope is constant. Here the slope is constant. Why temperature is constant? But here temperature is not constant. If you go from this point to superheated, temperature always increase. So temperature always increase, slope always increase. Slope always increase. So on the molar chart, the pressure line will shoot off in the upward direction. That means, see, in the wet region it is like that. In the wet region it is like that. But in the superheated it is like that. In the wet region it is like that little bit. But in the superheated it is like that. Why? Because in the superheated temperature energy will higher and higher. That means temperature is more and more. If we do that after saturated vapor, the temperature will add. That means temperature will add, that means slope is higher. So this after saturated vapor line, the slope is higher as compared to wet region line. In the wet region line, temperature, pressure are constant. So this is a constant pressure line. This is a pressure constant P1. This is pressure constant P2, and this is pressure constant P3, and in this pressure will increase in this direction. In this direction, pressure will increase. That means after the in the superheated vapor, more energy will add. That means more energy will add more slope. So see, at this point, if you take at this point, this point have a higher slope of this point. And this point have a higher slope at this point. Why? Because you increase the enthalpy. That means you increase the temperature. Temperature T1, temperature T2, temperature T3. You increase the temperature. If you increase the temperature at this point, so this point slope is higher than this. This point slope is higher than this. So it will look like that. Look like that. Look like that. It is clear, everyone, please? It is clear, everyone, please? It is clear, everyone, please? Nuru, Uttam, Everyone please beta, this is clear? Okay, this is clear? Uttam, it is clear beta? So it is true. It is true. So this is very important question, I am telling you. Okay, that means if you increase the temperature, slope will increase. Which line? Constant pressure line slope will increase. So in the superheated region, the temperature is higher than in the wet region. This, at this point the temperature pressure are same, but after this point this is a constant pressure line and this is a constant temperature line. This is a constant temperature line. This is a constant temperature line. Okay? Okay beta? Now next. Next. Now next, if you take this process, if you take this process, just think that this is a T and S diagram. This is point number A, one process, another process, another process, another process. I give you direction, it is this direction, it is in this direction, in this direction, it is in this direction. So it is E, D, T, B. Please identify all the process. 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 B to A. First, what is the process B to A? What is the process B to A? Just reply, what is the process B to A? Complete information. Complete information. Irreversible. Why it is irreversible? No. Why it is irreversible? See, SA is equal to SB. SA is equal to SB. That means this is your, this throughout SA, this is isentropic. Heat addition, heat rejection. Everyone please. Isentropically heat addition or heat rejection. Just focus on the arrow mark. This is heat addition, heat rejection. See, temperature will reduce or not? In this process, temperature will reduce. When the temperature will reduce, there may be chance that heat will reject from the system. If the system have a temperature reduction, then there may be chance that heat will reject. So it is isentropic heat rejection process. Isentropic heat rejection process. Isentropic heat rejection process. It is clear? Process 1. This process is clear, everyone please? This is process clear? See, B to A. We can judge like that. TDS is equal to DH minus VDP. We know that. This one we know that. Now, SA is equal to SB. That means this is 0. This is 0. Why? Because SA is equal to SB. Now, what is DH? This is for ideal gas. Right down. In question it is given. Ideal fluid gas. It is given. And for ideal gas, what is DH? CPDT. What is DH? CPDT. Now, so what is the equation here? CPDT is equal to VDP. So this specific volume is approximately, so this, the changing is dt is directly proportional to dv, right? So if we go from B to A, if you go from B to A, if you go from B to A, temperature will reduce. temperature will reduce from B to A. So if the temperature will reduce, pressure will also reduce. Pressure will also reduce. That means from B to A, pressure will reduce. The pressure will reduce. It is expansion or compression? It is expansion. That means this is expansion. So we cannot write this is at heat rejection or addition. Very important. This is the confusion. This is your isentropic expansion process, not compression. Why it is compression? It is expansion. Pressure will reduce. Pressure not increase. Pressure reduction. When heat will reduce? No, it is not that. In general, beta, isentropic process, there is no any heat transfer. In general, we can say that. In general, there is no any heat transfer. So better you can say that isentropic process. Better you say that compression or expansion. Constant pressure, constant volume process, better you can say that heat transfer. There are two processes. One is the isentropic, another is pressure constant, volume constant. So in the isentropic process, in general, there is no any heat transfer. Only takes place expansion or compression. But at the constant pressure and constant volume process, there may be heat transfer. So when we judge the isentropic process B to A, there is an isentropic process. If there is an isentropic process, that means this is the isentropic expansion. That means this is your expansion process. This is your logic. Just keep in mind. Okay? So this process B to A, this process B to A is isentropic expansion process. Now, we'll go to the next. Where we can draw? Okay, we can draw here, no problem. So, for the second, if you take, then you take this one, E to A. E to A, what is that, beta? E to A, what is that? Just reply your answer. Process E to A, what is that? Process E to A, what is that? Constant temperature, isothermal what? Isothermal what? Heat addition, rejection. Isothermal what? Heat addition or rejection? Please reply. See, TdS is equal to dH minus, take anything, VdP. Yes or not? Yes or not? Now, here, temperature is constant. That means this is 0. This is what we call Cp dt. Cp dt. And this is 0. Temperature is constant, na? T is constant. That means TdS is equal to minus dP. You can apply this equation also. TdS in positive sense. TdS is equal to du plus PdV plus PdV. Both equation. In this equation, you can have more information as compared to this. So du is what? Cv dt. And dt is 0. Then TdS is equal to PdV. Now, TdS is equal to PdV. Very important. See this one. Temperature is constant. See this one. ds and dV. ds and dV. ds and dV. 1 second. ds and dV. So, in this case, E to A, entropy reduce. Entropy will reduce. If entropy will reduce, a specific volume will reduce. A specific volume will reduce, density will increase. Density will increase, specific volume directly inversely proportional to density, so density increase. When the density increase, compression or expansion? Compression. If you compress that, energy will increase. So during the compression, what is that? Heat will reject or heat will enter? Heat will reject. If you compress anything, heat will reject. So volume will decrease. That means you compress the cylinder. And if you compress the cylinder, heat will reject to maintain constant temperature. So if there is a cylinder, if you compress it, when you compress it, temperature will increase. But you want that temperature is constant. So during the compression, you want that temperature is constant, you must be reject a heat so that the temperature throughout the system is constant. Right? If you compress anything, ideal gas, automatically its temperature will increase. But you want that temperature maintain constant. To maintain the temperature constant, you are constant to that reject the heat. That means this is your E to A is your constant temperature heat rejection. Constant temperature heat rejection. That's isothermal heat rejection. Thermal heat rejection. Okay, now A to C and D to B. Just reply your comment. A to C and D to A. What is the process? Just reply. That means this is like that, beta. It is like that. This is your, this direction is this direction. This is your A, C, D. A. Right. What is the process? Just reply, everyone. What is the process? Oh, A to C. A to C heat addition. Which process? On which process heat will added? Nuru? Heat addition. At which process? There are two processes. A to C and other D to A. Yes, heat adding. Nuru, you are right. A to C heat addition. Which process? Which process? It is from the graph that temperature will increase, that means heat is added. In the graph temperature will reduce, heat rejection. It is right. But which process? But which process? Uttam, please reply, beta. A to C temperature will increase, so heat added. D to A temperature will reduce, so heat rejected. What is the process? Please reply. What is the process? Please reply, everyone. What is the process? Please reply. What is the process? See, if you want the process, apply TDS 2 equation. That means first we apply TDS 2 TDS equation. What is that? TDS is equal to du plus PdV, and second is TDS is equal to dH minus VdP. Yes, you are right. Now, what is du? CV dt, yes or not? And if we take this process A to C, this is for A to C and this is for D to A. So A to C, CV dt constant volume, so this is 0. Why? Because volume is 0. Okay. Now, what is that? TDS is equal to CV dt. So, what is the slope? dt by ds. This line slope is dt by ds. What is the slope? dt by ds. So, what is the slope? dt by ds is equal to what beta? T by Cv. Now in this case, what is dH? Cp dt, and this is 0. Why? Because pressure is constant. Cp dt, if you take A to B, pressure is constant. So this dt by ds, it is a constant volume process, and this dt by ds is equal to T by Cp at pressure constant. Now, which is higher beta? Cp is higher than Cv. Yes. Cp is higher than Cv. If Cp is higher, then the slope is lower. That means dt by ds at pressure constant is lower than dt by ds at volume constant. That means lower constant pressure line have a low slope on a TS diagram as compared to constant volume line. So which is slope is higher? Which slope is higher? Just reply. Which slope is higher? Just reply. Which slope is higher? Just reply. A to C slope is higher. The slope is higher. That means this is your volume constant and this is your pressure constant. That means A to C is heat addition at volume constant, D to A heat rejection at pressure constant. It is clear, everyone? It is clear, everyone? It is clear, everyone? It is clear, beta? It is clear? Everyone please reply. It is clear or not? Everyone should reply, beta. It is clear or not? Everyone should reply. It is clear or not? It is clear, beta? It is clear, Nuru? Okay, it is clear. Okay, okay. Now I give you another short. See, I give you complete information for that. We take some equation in the thermodynamics. I have some equation, and please identify for that equation. Yeah, what is the assumptions behind that equation? Okay. So we bifurcate it. First, the equation is dW is equal to PdV. This is the first equation we take. What is the assumption behind this equation, beta? Please reply, everyone. What is the assumptions behind this equation? Please reply, everyone. What is the assumptions behind this equation? dW is equal to PdV. What is that? This is your thermodynamic work. This is your thermodynamic work. Okay, close. No, you are wrong. Uttam, it is not necessary that it is a closed system. Yes, that's why I give you. Uttam, it is not valid for closed system. It is valid for both system. Just listen 1 minute. See, if you have this system like that, this is our system. Please tell me, it is open system or closed system? It is open system or closed system? Please tell me, it is open system or closed system? It is open system or closed system? Obviously, sir, it is open system. Why? Because mass is in. During open system, when the fluid is in, this boundary will displaced and the piston will pushed up, and that is PDV. That is PDV. That means this work will, the piston will displaced due to the displacement of a boundary, and that displacement of a boundary is occurs in also open system. So this equation, it is not necessary that it is open closed system, it is open system also. Very important, I'm telling you. That's why I'm taking. This is the cancer. This is the cancer of the thermodynamics. 99% say teachers and students say that this is only for open closed system. No. What is the actual validity of this equation? I am writing here. So first, this is work transfer. Work transfer. Now this work transfer is only moving boundary work. That means under what situation, under what condition, under what system you are moving the boundary, you are displacing the boundary, you are expanding the boundary, you are contracting the boundary, either it is open system or a closed system, this PDV work are valid. It is not necessary that this is valid for closed system. No. Only thing is that boundary will move, and boundary will move either any system. This is open system, or boundary will move either in closed system. See, this is a closed system. This is our closed system. You supply a heat here, so boundary will displaced. This boundary will displaced, and this is your PDV. So in the both case, this is open system. This is closed system. So this is only moving boundary work. Number first. Number second, simple compressible substance. Substance. This is valid for simple compressible. What is the simple compressible substance? What is the simple compressible substance? That substance is free from the magnetic effect, electrical effect, and surface tension effect. That means if you calculate this energy transfer, during that energy transfer, we can neglect the electrical effect, magnetic effect, and surface tension effect. In that condition, that is this substance is called simple compressible substance. That means in the absence of electrical, magnetic, and surface tension effect. Right. So there is a first and this is second. Now the third validity is, third validation is under quasi-equilibrium process. That's it. And take a note. It is not necessarily that it has to be the closed system. This is very important. It is right? It is clear, everyone? Please reply in the chat box. It is clear? It is clear, everyone, please? It is clear, Uttam? Uttam, it is clear, beta? Your confusion is clear? Yes. Your confusion, Uttam, confusion clear? Okay. Uttam, I think not able to listen. Okay, no problem. Now, this is the first equation. We take second equation. We take second equation. What is that? dq is equal to du plus pdv. What is the validity of this equation? What is the validity of this equation? What you know about this equation? Just tell me, point by point. Point by point, what you tell about this equation? Just just reply. Okay, no, both. Yes. Okay, both system, no problem. Next. No problem. See, see beta, I give one sort of this. If you someone ask what is this equation? Total internal energy, open and close both. See, I give you, okay, stationary, correct. You are correct, stationary. Now I compile all the output of yours, right? See, first write down, this is for first law, very important. First law for closed system. This is very important. It is not for both system. Why? See, the interaction, see beta, what is the closed system and open system? In the closed system, interaction only by the heat, energy. In the closed system, the interaction only by the energy. But in the open system, interaction also by the mass. So in this case, there is no any mass transfer. Energy transfer, this is the energy transfer. So only there is an energy transfer. So this is for closed system. No any mass transfer is there. You think about this equation, sir. This equation is valid for both. So this equation is valid for both. No, it is an energy transfer. Energy transfer in the form of heat. Energy, it is not a transfer. It is a property. This is the transfer. This is a transfer phenomena. That means it should cross the boundary. And this transfer is the energy. This is the system property. It is not transfer. It is the property of the system. U2 minus U1. So it is a property. And this is a transfer phenomena. This is a transfer. Displacement work. Yes. Available. No problem. This is transfer phenomena. And this transfer is in the form of work. In the form of work. And work is the form of energy. Work, it is in the form of energy. So there is no any transfer of mass in this case. Only the transfer of energy. So it is for closed system. The first punch is this. Now, next punch. Neglecting change in kinetic energy and potential energy. That means if you neglect the change in kinetic and potential energy, that system is called a stationary system. That system is called a stationary system. That means first is that this is the first law for a closed system. Second is, sir, it is for a stationary system. Why? Because during the application of this equation, we can neglect the change in kinetic energy. That means velocity change is 0 and potential datum height change is also 0. Same, change is same. That means change is 0. Number third is very important. PdV. There is PdV. There is PdV. That means work is defined. What is the work defined? PdV. And PdV work is the quasi-static work. Right? See? This is under quasi-static process. So the third thing is the process is quasi-equilibrium process. That's it. That's it. Nothing else. Don't think extra other than this. It is clear, everyone? It is clear, everyone? It is clear, everyone? Uttam, it is clear, beta? Okay. Now, Nuru, it is clear, beta? Okay, now next. Next equation. Next equation. If you look about dq is equal to du plus dw only. Now, what about this equation? Please reply in the chat box. What about this equation? Please reply in the chat box. Yes, close. Now next. Next, anyone? Reversible and irreversible. Yes, this is very important. Uttam, this line is very important. Yes, both. Yes, correct. First, you write, this is for first law for any process. Why? Why it is any process? Uttam, why it is any process या both process? Why it is first law for any process या both process? Why, Uttam? Just reply. Why it is any process? Why it is any process? Just reply. Why? Because work is not defined. If the work is, if work is PdV, then it is reversible. If the work is other than PdV, then PdV, like paddle wheel work, like paddle wheel work, and this is your irreversible. So at this junction, work is not defined. At this junction, work is not defined. So it may be reversible, it may be reversible, or it may be irreversible. That means this is for any process. Now, what is the next? Closed system. It is clear, everyone? It is clear? It is clear, beta? Everyone, please. It is clear, everyone, please. It is clear? Yes. Okay. Now, next, take a next problem. Next thing. Number 4. If we take this equation, TdS is equal to du plus PdV. Tell about this equation. Tell about this equation, beta, please. TdS is equal to du plus PdV. What is this? Reversible. Other than that? No, Uttam, you are wrong. Uttam, you are wrong. It is not reversible. It is for both. This is why we take a star. That's why I'm taking a star mark here. See, listen very carefully. T S2 minus S1. T S2 minus S1, it is a property. U2 minus U1, it is a property. P V2 minus V1, it is a property. So it is a property relation like PV equal to MRT. It is a property relation. So it is valid for any process. T S2 minus S1, U2 minus U1, P V2 minus V1. Think like that. So it is a properties relation. So it is valid for both, either reversible or irreversible. Number first. How to solve this equation? Number second, how to solve this equation? How to perform? If you solve this equation, listen very carefully, beta. Never found this type of statement in YouTube or another book. How to perform this? Why? Because you think this is a method. You can think like that. This is a mathematical equation. How to solve? How to solve? How to solve? This is, I'm giving a challenge. This is very important. How to solve this equation? This equation solved by the integration. Yes or not? If you do the integration, there must be a path. That path is only reversible. Once the equation will get solved, that solved equation is applicable for both processes. But the integration is only for reversible process. Once integration is done, the final outcome is for any process. This is the beauty of this equation. So we can write here for any process. For any process. Yes, masterpiece. For any process, right. This is for any process. Why? Because this is property relation. Why? Because this is properties relation. Now, see, very important. So integration of this formula has to carried out by reversible only, reversible process only. once the integration once the integration done, can apply for any process. It is clear, everyone? It is clear, everyone? Other thing is are same. It is clear, everyone? Please reply in the chat box whether it is clear or not. Thank you, Saurabh. It is clear, everyone? Okay. So this equation are two-step equation. Two-step equation. First do the integration, but mind it, many students get confused here, sir, this is for any process, so we will apply for irreversible also. Yes, you can apply, but if you solve this equation, you have solved this equation through the integration, and integration only put through a path. Which path? We know that path. And which path you know? Thermodynamic path we know. And what is the thermodynamic path? Thermodynamic path is a reversible path. So we can integrate for a reversible manner. Once it is integrated, it is applicable for both process. Okay, now next. This is the fourth equation. Now we take fifth equation. Equation number 5. Equation number 5. What is that, beta? We take this equation. TdS is equal to du plus dw. Just chill. Just chill. चलिए बेटा, चिल कीजिए, बताइए जरा इसको. Just explain that one. Please reply in the comment. Please reply in the comment box. Please reply in the comment box. Please reply in the comment box. Uttam, please. Other than that, what do you comment of this equation? See, see, TdS, TS2 minus S1, U2 minus U1, but this work is not defined. This is the property TdS2 minus S1, U2 minus S1, but work is not defined here. So you can say that, sir, this is for any process. Yes, but the here dq, here what is that, beta? How can we write? dq is equal to du plus dw. This is the first law of thermodynamics. Now, for the reversible process, we can write here TdS. This is only for reversible process, mind it. So, TdS is equal to du plus dw. So, this is for reversible process, but work, it is not defined. It may be reversible or it may be irreversible. So, if the work is irreversible work, that means paddle will work. So, all the process are irreversible. If the work is reversible, then all the process are reversible. That means it may be defined for both. It defined for both process. That means we can write that reversible process, but here dw is anything, कुछ भी हो सकता है, anything, because it may not be a simple compressible substance, it could be another case. It could be another case where other form of work also there. So we cannot say that this is only for, yes, agar simply you can simply that this is a reversible process. No, but work is not defined. So if the work is defined PdV, so TdS equal to du plus PdV, this is for any process. But before that, only define this one, this for reversible process, but work cannot be defined. If work cannot be defined, so we cannot say that their work will W is anything, because it may not be a simple compressible substance. That means it may not be a reversible process. It could be other case where the other form of work also there, like a paddle wheel work. So we cannot say that this is for which process. But yes, according to this one, you can say that. So what is your exact answer? Sir, this is also applicable for any process. Okay, now last 6. This equation you can raise. W is equal to minus integration V1 to V2 V1 to V2 no, V1 to V2 नहीं, P1 to P2 integration P1 to P2 VdP. Please everyone, later. What is this equation? What is the equation tells that? Please everyone reply. Beta. Please everyone reply. I am waiting for your response. What is this? Flow work. Okay, that means okay. Now, other than that, yes, flow work. Okay, other than that, okay, I am asking something. This is the reversible work or irreversible work or anything? This is reversible work or irreversible work or anything? Yes, it is a flow work, open system work. This is for reversible work or irreversible work or anything? Uttam, please. This is for reversible work, anything? No, it is a reversible work. Now, third thing. First is the flow is irreversible. This work is input work or output work? This is an input work or output work? This is input work or output work? This is input work or output work? This is input work or output work? Input work, correct. This is input work, correct. Why it is input? Why? Because see, work done on the system is positive when there is a closed system, right? But this is open system. In an open system, this is your input work. That means this is a compressor work. If you write like that, W of a compressor work, so it is integration 1 to 2 VdP. This is your, if you write compressor work, you write like this one. So this is your input work. Very important. Input work. That means this work will work absorbing device. Yes, you are right, Uttam. So if you write compressor, in the compressor we give the work, and so the compression work is this one. It is like that. If you write compressor here, so no need write to negative sign. Only write. If you don't write a compressor work, put a negative sign. Okay. Now we'll discuss this one some details manner. Okay. So this is your any reversible. Very important. What does it mean by any reversible? Any reversible. Any reversible, that means work input reversible, work output reversible. That means any reversible. Any reversible, number first. Number second, steady state. Steady state. That means the property within the system is not changing. If you take a control volume, in that control volume, property is not changing with respect to time. Steady flow. Steady flow. Steady flow. Single inlet, single outlet. Single inlet and single outlet. Right. Next, change in kinetic energy and change in potential energy are negligible. That's it. This is your validity of this equation. First, second, third, fourth, fifth, and this is sixth. It is clear, everyone? It is clear, everyone? Single inlet, matlab there is a compressor have a single inlet, single exit. It is clear, everyone? If my video go to my detailed video on thermodynamics, we can derive this equation with these assumptions. We derive this equation, in between the assumptions are coming in front of this. So if once we have derived this equation, these assumptions are automatically come out in the picture. So other than that, there is no any necessary to the assume. Okay, it is clear. That means this is input work, compressor work, any reversible work. This is a reversible work. That means if this is a reversible one now, and if it is a compressor, so compressor is a work input device, and if the compression is irreversible, then this is a minimum work. This is your minimum work in the form of compression. If there is a output work and there is a reversible, then there is a maximum. So beta, you can see that this thing very important. Reversible work. We can say that reversible work. So reversible work is two type. Yeah, either work input, work output, or work input device. Work input device. So reversible, that means it is not always a maximum. If there is a work output, then we want that maximum work output. If there is a work input, then we want minimum work input. So if reversible work input device, the work is minimum. If reversible work output device, work is maximum. So if there is a work output device, 1 to 2 integration 1 to 2 PdV. Okay. Work input device W 1 to 2 integration 1 to 2 minus VdP. So this is your sometime called non-flow work. Non-flow work, and this is called flow work. This is called flow work. So flow work is this is reversible. This is also reversible. This is also reversible. But this is a maximum. This is a minimum work. Okay. Okay, beta. It is clear here. It is clear. Now, if it is clear, take another salt. Take another salt, beta. Now take This is very interesting problem. See, a spring is slowly stressed. Slowly stressed by a tensile force F is equal to 1 kilonewton thermally at 300 Kelvin. What is the rate of change of entropy for the spring per unit length? Okay, you don't solve. First, you give me a reply. If there is a spring and this is our system, spring is our system, you can stretch it with a tensile force F. Its system entropy, what is the system entropy? First, delta S should be less than 0, delta S should be greater than 0, delta S should be greater than equal to 0. First, second, third and fourth we cannot say. First, give me this reply. If there is a spring and that spring we stretched it through a tensile force, stretching through a tensile force, whether its entropy will increase, decrease, we cannot say. Just reply. Everyone, please reply. Everyone, please reply. Everyone, please reply. First, think that. B. Oh, you have B option. Okay. Entropy will increase. If you stretched, this is a stretching. So you see that entropy will ऐसे ही हवा में उत्तम. Anything you say? No. Other than that, if there is a spring and you stretch the spring and you take a spring as a system, what is the entropy of the system? Whether it is increase or decrease. Uttam says it is increase and this is wrong. It will decrease. It will decrease. How? See. What is we know that? TdS is equal to du plus dw. Yes or not? Yeah, you can say that. Okay, no problem. And what is du? Spring work. D of spring. dw of spring. Spring. And this is isothermally. We stretched isothermally. That means this may be 0. Why? Because it is a function of temperature. So it is 0. Its magnitude is very less. So what is that? TdS is equal to d of work of spring. Yes. Now, what is the spring work? What is the spring work? If you stretch and it will displace delta x dx. So what is the spring work? What is the spring work? Minus F into dx. Yes or not? Negative work. Negative stretching negative. If you stretch it, it will compress. So the work is minus F dx. Now, if you solve this one, so what is the ds? That means, what is say that entropy of the spring per unit length. Entropy of the spring per unit length. Yani ds by dx. Yes or not? ds by dx is equal to what beta? Minus f by t. Minus f by t. If you have this, if you have 1000 Newton, this is F you have. Now T you have, put this one. So see beta, this is negative. That means this is less than 0. It is clear? It is clear? How to play the thermodynamics? This is the beauty. Never found in any lecture beta, I am telling you. Okay, you forget negative. So if you forget negative, entropy must be vanishes anything. Okay, just reply, just think very carefully. Don't forget anything. Okay, if forget anything, so everything is gone. Okay, no problem. Hence, when you stretch the spring, this is all are the entropy question. If you stretch the spring, the entropy of the system will reduce. What is that? If you stretch the spring, entropy of the system will reduce. Entropy of the system will reduce. Okay. Okay, beta. Now we take one very good problem for you, and that problem, this is very intelligent problem. I am telling you. What I am writing here, that problem never found in any book. See. Listen very carefully. See, heat transfer from a heat source, heat transfer from a heat source. But I am requesting you, this is a very intelligent problem. I am telling you, 90% teacher also get torque of this problem. 90% teacher. 90% teacher. Okay, so please be careful. So thank you, Gopal. Heat transfer from a heat source at 1000 Kelvin to a simple compressible substance, through a simple compressible substance with system boundary temperature of 500 Kelvin. Okay, now during the process, please write down, during the process, please write down beta, during the process, the total heat transfer, very intelligent problem, total heat transfer of 1500 kilojoule, very important, to the system, read carefully. During the process, entropy of the system increase, by 5 kilojoule per Kelvin. Entropy of the system increase by 5 kilojoule per Kelvin, and internal energy increase by 1000 kilojoule, very important. Okay, the system mass is The system mass is 1 kg. Just I give you 1 kg. What is the statement? What is the statement? True and false. What is that? State whether true or false. State whether true or false. What is the statement? Number first, A. Number A. W1 to 2 is equal to integration P dV is equal to 500 kilojoule. No problem at all. And option B, option A option, it is true or false. B option, it is true or false. That means entropy generation is generation due to external irreversibility is equal to 2 kilojoule per Kelvin. 2 kilojoule per Kelvin. Please, everyone. 2 kilo. This, whether it is true or false, this is true or false, this is true or false. This gives you a better understanding of the entropy question. This is such a unique question which will apply all the formula and concept of that. What is that? A heat transfer from a heat source. There is a heat source, and what is the source temperature? 1000. I am giving you a challenge. Please correct it. To a simple compressible substance, that means a substance is free from the electrical effect, magnetic effect, and surface tension effect. Okay, no problem at all. With a system boundary, that means what is the system? That boundary temperature it is given 500 Kelvin. Okay, no problem at all. During the process, that means during this heat transfer, total heat transfer to the system is 1500 kilojoule. Total heat transfer 1500 kilojoule to the system. During the process, when you transfer the heat to the system will increase its entropy 5 kilojoule. Entropy of the system increase 5 kilojoule per Kelvin, and internal energy also increase by 1000 kilojoule. So whether this statement is true or false, W1 to 2 is integration PdV 500 kilojoule or not. Entropy generation due to external irreversibility is 2 kilojoule per Kelvin or not. Please start this problem. So please everyone listen very carefully. I am telling you. So what is given? I am giving such situation. Please listen this one. I give you a situation. If you have after the lecture, if you see the video, just pause. Everyone, I am telling you, just pause the video. Just pause the video and try to solve self. Then go through the solution. Please, I am humbly request. But now you are on live on this in front of me, so you can see this. See, this is our system. This is our system. Very correct. No problem at all. This is our system, and this is our system boundary. This is our system boundary. No problem at all. This is our system boundary. This gives the very good concept. This is our system boundary, and this system boundary temperature, that means this system boundary temperature, it is given 500 Kelvin. No problem at all. Now from the source, this is temperature of reservoir, and it is given 1000 Kelvin. From that 1000 Kelvin, we transferring heat to it. At what amount? That means Q1 to 2, it is 1500 kilojoule. This is given. Now, what is given next? Next is given change in entropy of the system. That means increase. That means S2 minus S1. It is given how much? 5 kilojoule per Kelvin. No problem at all. Internal energy increase. That means U2 minus U1. It is given how much? 1000 kilojoule. No problem at all. Mass of the system, it is given 1 kg. Okay. Mass of the system, it is given 1 kg. Okay, no problem. Now, What is the first law? What is the first law? What is the first law? First law is say that sir, dq is equal to du plus dw. That means Q122 is equal to U2 minus U1 plus W122. Now, U2 minus U1, you have 1000 kilojoule. Heat addition to the system, that means it is positive, it is given how much? Heat added 1500 kilojoule. So, what is W122? 500 kilojoule. 500 kilojoule. So, you just go and tick it is true. It is true. Yes, it is true. Everyone please, it is true. It is true. You go and tick it is true. Yes, everyone please, yes. It is true or false? Why? Because see, 500 kilojoule and you have also 500 kilojoule. It is true. Everyone please. Please reply. It is true? No, it is wrong. Why it is wrong? Why? Because, see my dear, this is given that W122 is false, is integration 1 to P dV. That means this will done through this integration, but we cannot integrate. Yes or not? Yes or not? That means this done by the integration, but we cannot integrate. There must be internal energy. That means this is your true. That means, since what we can write here? We can write, sir, what we can write? We can write, sir, W122 is equal to 500 kilojoule. Okay, no problem. This is okay, no problem. But integration P dV only for quasi-static process. Yes or not? Only for quasi-static process. And quasi-static process are internally reversible process. But you cannot say here this is internally reversible or irreversible. Why? Because entropy of the system will increase. That means internally it is not reversible. See beta, entropy of the system will increase. S2 minus S1 is greater than 0. That means it is not internally reversible. That means if it is not internally reversible, this will not applicable. Why? Because this is applicable for the quasi-static process, and quasi-static process will apply for the internally reversible process. But there is no any, so how can you say that, sir, it is not internally reversible? Why? Because the system entropy will increase. That means system entropy will increase. That means system will irreversible. This is the logic. That is only for this quasi-static process, only for internal reversible process. Only for internal reversible process. Okay. So here, okay beta, now we'll check this is internally reversible or not. We'll check from the entropy. So what we know that second law? What we know that second law? Very important. What we know that second law? Second law says that, sir, S2 minus S1 is equal to Q122 by T plus S generation. My dear, Please, this is S generation. My dear, I am telling one subtle concept here. In application of this formula, there have lots of confusion in the student community. What is that? What is this temperature? What is this temperature? This is system boundary temperature or surrounding temperature? Please reply. Why? Because beta, there are two temperature it is given. There are two temperature. One is the system temperature, one is the surrounding temperature also given. So which temperature you have to suppose to put here? Which temperature? This is very important concept is there. Which temperature? Which temperature you put here? It is whether system temperature, system boundary temperature or surrounding temperature. I give you one subtle concept is there. If there any chance to put this temperature, just go through this information. What you want? You want internal entropy generation or total entropy generation. Why? Because this generation, see beta, this is your point function. This is your point function. Why? Because it is a property. This is your point function. But this is your path function. This is your generation is the path function. That means if there is a reversible, that means this is an internal reversible, this is 0. And this is greater than equal to, this is greater than 0 if there is irreversible. So entropy generation, it is not a property, it is a path function. But this entropy change, it is a property. It is not depend upon the process, but it depend upon the process. So it is a path function. First thing is clear to mind. Now beta, how to apply? This is very important. Just I am giving you one. So see, if I have S2 minus S1, if I have S2 minus S1, what is S2 minus S1? This is 5, you have 5 is equal to, what is heat transfer? We have, what is the heat transfer beta? 1500. Now, if we put the temperature of the system boundary temperature, that means 500. That means 500. If we put the T is the system boundary temperature, the generation is always put internal. This is very important. So here we put S generation internal. Why? Because this temperature is the system boundary temperature. System boundary temperature. So what is the beta S generation here? Right. This is the first equation. We can. What is the second equation? If you apply the secondly, what is the change in entropy? 5. And what is the heat transfer? 1500. Now, if we put, very important, I'm telling you, 19% students will get confused here. If we put temperature of the reservoir, that means surrounding 1000, very important. If you put 1000, see my dear, this S generation is total. This is very important. This S generation is total. That means this will depends upon this surrounding temperature. So beta, while you solving the entropy question, generation question, just carefully read whether this is asking, whether the question is asking internally or total, globally. If we asking internally, don't think other temperature except that system temperature. If we asking total entropy generation, put the temperature of surrounding. That's it. No any confusion. Okay. So after solving this, what is the S generation here? Internal. S generation internal. What is that beta value? This is your 2 kilojoule per Kelvin. What is the total entropy generation? S generation total. This is your 3.5 kilojoule per Kelvin. Okay. Now, one thing. Now the problem is going into deeper and deeper. The problem is going into the deeper and deeper. So we have internal entropy generation and we have total entropy generation, but we don't have a external entropy generation. So here we know that S entropy generation total is equal to entropy generation internal plus entropy generation external. Yes or not? So entropy generation total, it is 3.5, I think, and internal 2. This is your S generation external. So what is the S generation external? What is the S generation external? This is your 1.5 kilojoule per Kelvin. See the second option. See the second option. If you see the second option, see very carefully. S generation due to external. Very important. S generation due to external is 2 kilojoule per kg Kelvin. Per kilojoule per Kelvin. But here how much? Here how much? Here how much? 1.5. So the second option also false. The second option also, this is false and this is false. It is clear, beta, everyone? Please reply in the chat box. This is very intelligent problem. If you go to the examination, into the examination, please read this question carefully and try to solve your entropy problem. Never get a mistake here. It is clear? It is clear, everyone? So how to find internal generation? How to find external entropy generation? How to find total entropy generation? What we the temperature value we put and what we temperature value doesn't put. This analysis should be very clear in the examination when you are enter the examination and solving the entropy problem. I mind it. Okay. So what is the common is that? So beta, see, this is, see beta, so here this is your S generation internal. That means S generation internal is equal to 2. That means this is greater than 0. That means internally irreversible, right? Internally it is irreversible. Yes or not? So W1 to 2 integration PdV cannot be applied. Cannot be applicable. It is clear, everyone? So beta, I have lots of things, this one. Such type of analysis, I have lots of the problem. Lots of the things, such type of things we have. I am coming in the next schedule. I've just give you all the things. Heat transfer and also fluid mechanics. Such type of level we will enter into the fluid mechanics also and heat transfer also. This is nothing beta. I am doing nothing. I am doing just treatment of your cancer in that subject. Where is the cancer? As a teacher, I know. As a doctor, I know where is the cancer of that patient. I just focus on that point and kill that virus. That's it. Everything you are okay. Every part of the body you are okay. But we have the killing at the point, at the concentrated point. Don't extra. Don't think extra. Other thing is very good. Just treatment of the cancer. That's it. This is a very big syllabus. you study very thoroughly. I know as a student, I am also study very thoroughly. But during the study, during the revision, during the preparation, during the PYQ, lots of confusion in the mind. And that confusion is start to create a cancer. So at that situation, you just search this type of video and listen very carefully. This may help lots. Okay? Now, today up to this. So how is the session, beta? Please reply in the chat box. Uttam. Maja aa gaya na? TDS equation. Yes, Uttam. Yes. I know where is the problem. Everything is all right. If there is some time in the front of you, after few days, we will enter into also power plant. Also, we'll say that. Nupur, how to maintain consistency about it? Not maintain a consistency. Don't think very lengthy. Why you are think we maintain the consistency? You already have a consistency. If you sit, this is the, I give a certificate. If you have entertained this 3-hour session from initial to final, there is no need for consistency. It already inbuilt you. Don't bother about that consistency. You have a consistency, but take an interest for that. How to approach each and every subject have a different approach, beta. Each and every subject have a different approach. You may not put all the subject at the same approach. If you approaching the same approach, see, if I am in front of you and take a very big problem, numericals, it is not useful to you. This is the smart study, so that you can pick. Your treatment is where you have a cancer. Don't treatment full body. Where you have a problem, just go through that. That's it. Other thing is very smooth. Okay, Nubru? It is okay, beta? Everyone? It is okay, na? There is no any problem other than Uttam. Is there any confusion, beta, in the thermodynamics or in the upcoming lecture? I am coming in with you in the live at fluid mechanics and heat transfer. Such a fantastic content I have. I give you free, no problem. And this video repeat many times. I have lots of questions, beta. I have lots of questions, but there is a time constraint, no? So, okay, no problem. So we will meet. I think 27. I have a session 26 or 27. So just I give you no problem. I give the information link in the YouTube channel and just go through that, and we will discuss lots of question in the fluid mechanics. See, this is my the step by subject. First is thermodynamic, second is fluid mechanics, and third is heat transfer. See, heat transfer is the subject which is a combination of thermodynamics and fluid mechanics. Why? Because in the heat transfer, you study the Prandtl number, and Prandtl number relate the boundary layer thickness of velocity and thermal. So thermal you have completed. Now our next is boundary. Combined with that, and you play with the heat transfer. That's why we can take. Okay? So this is the beauty of the subject. All the subjects are linked, but the approach are differ. Okay, beta? Thank you. Bye-bye.